Hi, now let's look at problem 269. Alien Dictionary. There is a foreign language which uses the Latin alphabet, but the order among letters is not A, B, C to J to G in English, as in English. You receive a list of non-empty string words from the dictionary, where the words are sorted lexicographically based on the rules of this new language. Derive the order of all letters in the language. If the order is invalid, return an empty string. If there are multiple valid order of letters, return any of them. A string A is lexicographically smaller than a string B if either of the following is true. The first letter, where they differ, is smaller in A than in B. There is no index I such that AI is not equals to bi and a.length is less than b.length. Okay, let me read the question to make sure I understand it. There is a foreign language which uses the Latin alphabet, but the order among letters is not A, B, C to G as in English. You receive a list of non-empty strings words from the dictionary, where the words are sorted lexicographically based on the rules of this new language. Derive the order of letters in this language. Okay, so we are given non-empty string words. Empty string list words. And words are sorted lexicographically based on the rules of this new language. Derive the order of letters in this language. If the order is invalid, return an empty string. Return the order or empty if invalid. There are multiple valid order of letters. Return any of them. Any order or empty string if invalid. A string A is lexicographically smaller than a string B. A less than B if either of the following is true. The first letter where they differ is smaller in A than in B. So AI less than BI. There is no index I such that there is no index I such that AI is not equals to BI and A.length less than B.length. Okay. Either of the following is true. Either A.length, B.length, so AI equals BI for all I. Okay. Okay, I think it is the lexicographic meaning here is the same as the one that we had in regular letters in English. Okay, so I think it's clear what it wants us to do. Now let's look at the example there. Sample input, we have G and O. So this means the order is G and O. Example 2, HRN, HRF, ER, ENN, RFNN, RFNN. Okay, so now we know that H is less than E. Actually, for the first and second, we compare it. First letter is the same, second letter the same. So now the third letter is different. Now we see that N less than F. And then second and third, H is less than E. Then the next one we see that R is less than N. Third one we see that E less than R. Now if we combine all of them, let's see what we got. N, F, R, and F, E, H. So from, let me mark it as 1. Let me write down in the beside. So 1, 2, 3, 4. So you got these 4 facts. 1 and 3. 1 and 3 give us R and F. And then 2 and let's see, 2 and 4. It gives us HER. HER. So in the end, we are gonna have say HER and F. HER and F. HER and F, yes, we got it right. Okay, so I think it's pretty clear what we need to do. And I think I just need to clarify the length. So before we continue, I'm gonna clarify one range of length words. Here we are given by 1 to 100. 2. Range of length of words I. So words I will be between 1 to 100. Okay, so I think that's all we need to clarify. Now let me think of some possible approaches for this to achieve this objective. Okay, so I think what we could do is we compare the first, if we could compare a string and the next string after it according to the order, because that is the closest ordering that we could, so that we could extract some facts about the order. So in the second example, we see that N comes before L. The way we check is that because the first character is the same, then we look at the second. Second is also the same, so we look at the third. could are different, so now we know that N comes before F. How about we build a graph then? So what we can do, I think if there is a, if you look at the English, so let me write down the findings. 1. Ordering is not, ordering has no cycle. Let's see what we need here. Order of letters, okay. Let me call it order of letters. Has no cycle. Okay. So what we can do, I think we could use the, what is it called again? There is a sorting that we solved before. It's a topological sort. Okay, so it's topological sort. So what we can do is step 1, we could derive ordering. Let's just say we build the graph. So we build graph based on the input. And then 2, we do a topological sort. To extract ordering. Okay, I think that should work. Third one, if there is cycle, return empty list. So if we look at the first example, then we have G point to O. So the ordering is GO. Second example, see that we can have N point to F, H point to E, and then R with point to N, E points to R. So from here we can build E, H, E, R, and F. That's how we got the order of letters. So I am gonna create a dictionary. Let's say order. So order is initialized to entity. And then I'm gonna go through the list of words one by one. So this would be
Okay. For I in range, length of words -1 because we want to check the current one and the next one. Cur equal words of I and words of I plus 1. So what we're gonna do is that we're gonna look through the character. For I in range, minimum of length of curve and the next. Then we're gonna check if curve of I is not equals to next of I, then we break. In the end, we check again if curve of I equals next of I, because it's possible that we look through it until the end and then it exits the loop, not because there is a mismatch, but because it's just the end of it. Then we continue. Otherwise, now we build the order. Okay, order has, let's try to use a default tick here to make things easier. So this would be default tick of deck. Okay, so I'm gonna do order of current I dot append next of I. And then after we finish every word, then we got the list of order. So now what we need to do is we need to get the order. I think this is similar to what we have done before. What we are gonna do is that we need to check if there is any previous in degree is what we need. Alright, so I missed one thing. Yeah. So in order is default tick of in, and then here we are gonna increase the in order the next of I plus equals 1. Now we create a to-do list, and we need to check whether there is any in order, if there is any character without any in degree. Sorry, not in order, so in degree. In degree. For character and degree. So for character and degree, let's just say count in that would be in degree dot items. If count is 0, then to do the append the character. Now the string, let's see what it is. It would be the alphabet. Like the order of letters. Okay, so letter we initialize to empty string. Then while to do char equals to do dot pop letter plus equal char, and then we look through the order. I mean the next character that we could, that is after the, so after we put this character, what is next that we could possibly take? So that would be for char. So let's call it next. For next, here at the char, I'm gonna call it curve for clarity. For next in order of curve, you're gonna decrease the in degree. In degree minus equals 1. If in degree is 0, then we add it to our to do the append next. After we are done with this, then we check whether we have completed all the character. So that would be letter.length. So we return empty. Sorry, let's return the letter if length of letter equals the length of order. Else, then return empty string. Okay. Now let me go through the code again to make sure I don't miss anything. First of all, I create an order dictionary. It will be using deck. And then there is an in degree to count the number of characters that should appear before the current character. Before a character, and then I'm gonna look through a pair of words in the words. So it has to be 2 consecutive words, and then I'm gonna find out where there is a difference, and that's how we know that there is an order that we could derive from this pair of words. And so we append the next character in the order into our order dictionary. And we also increase the in degree of the next character. Finally, we have to do this. If the in degree is 0, then it means we can put it into our order of letters. So we initialize a letter there to an empty string, and then I keep on popping the character and then add it to a letter. Finally, I check if I have all the letter in my output. If not, then there is a cycle, which means that there is no way to get the order because there is a conflict of order there. Now let me test the code with our input example. In the first one, I have G and O. So G has no in degree, so I put it in, and then I decrease the in degree of O, and then put it in, and then I have G and O. Second example, I'm gonna have N and F, H and E, R and N, E and R. So what I'm gonna do is that I'm gonna see the H has no in degree, and so on and so forth until I have the F. So in the end, I will get H, E, R, and F. Okay, so I think that should work. Now, let's look at a possible conflict here. How about I create an example? So let's call it example 3. Let's do it A, C, and A, B. And after this, we would have something like, let's see, B and C. Okay, so from the first two, we can tell that there is C and then B, and then the second and third, we can tell that there is A, then B. And then third and fourth, we see that there is BC, but it means that the B comes before C. So now our letter will have A only. So we return empty string at the end. Alright, I think this should work. So let me try input our code into the Neetcode platform. Order equal to default of text in degree equals to topic int. Now for I in range length of words -1. Sorry. Curve equals words of I. And next is words of I plus 1. Then we're going to check character by character and see in range minimum of length of curve and length of next. Then if curve of I is not equal to next of I think we should use a J there. Curve of J is not equal to next of J. Then we break. In the end, we check if curve of J is the same as next of J. Then we continue. Otherwise, we can tell that there is an order that we could derive from here. Curve of J equals, append next of J. Then we increase the in degree of next plus equals 1. To do is a deck for char and count, let's call it curve in degree dot items. If count is 0, then we append the curve. So we now could work on our output. While to do curve equals to do dot pop. And we append it into our letter, and then we check the next that we could take in order of curve. If in degree of the next is not 0, but before that, let's decrease it. If it is 0, then we add it into our to-do. Alright. Finally, we let here return letter if length of letter equals length of order. Oh wait, do we need to work on the order for all the letter, or just the one that we can derive? So R and L. Okay, here I'm gonna assume, hold on, HRN, HRN. How about the characters that I cannot derive? And if we have only, say, let me think. If we have A, B, B, let me work on another example. So if I have A, B, and then C, then I'm not gonna be able to tell what is the order for B. What I know is that A appear before C, but B can be anywhere. Okay, so in this case, I'm gonna create a visit set. Actually, let me think for a second. Visit set. Alright, I think I just append it to the end then. So what I'm gonna do is that I'm gonna look through all the words or words. So I'm gonna create a visit equals set. Then let's see what we can do here. Okay, so visit.update, or is it extend? Let me check. Title update set with list. Okay, we can use update. So update root.split. Now I'm gonna return the letter class visit. Say empty string.join visit minus set of letter. Letter.split. Actually, how do I set letter in string to Python set? I think I don't need to do it this way. Anyway, I think I can still split it. Let's try this. I don't think it could work. Okay, so I haven't finished this, else it's empty. Input words return empty. See what I missed here. How about we print the letter? Okay. Letter is empty. How is that possible? Let's print the order. G has 0. How about in degree? In degree. Oh, I see. So here, instead of looping through the degree, I should have checked all the words in order. Or I think I could just use the visit. Hold on 1 second. So we have order in degree. Okay, let's just do this first. Okay, here we are doing the wrong thing. Occur in order if in degree of curve is 0, then we append the curve. So now we see that we have GO. How is that possible? So it must be our logic here is wrong. So visit is a set. And later we split it into a set. Then we subtract it. How come it becomes CO? Now we need to see what is inside the visit. Okay, visit has GO. And what does this give us? OG. Okay, something is wrong here. The set of letter dot split GO. How come the set of letter split is GO? Yeah, that's funny. So letter is GO. Let me check how Python split a string into characters. Okay, so I can pass on to a list and then a set. Yep, now I got it right. And then here, ERHR, okay, this is a bit messy. And FHERN ER. Okay. Okay, something is wrong in the logic. So let's check that. Letter per curl, order of curl in degree of next minus equals 1. Okay, how about there is a cycle? Okay, so if C so if curl is in the letter, return empty string. Something is a bit funny there. So let me print visit and set of letter. Yep, the visit is not working. Visit, I'm gonna add the set. Okay. Okay, now we got it. Visit correct. ERH and F. How is it possible that we got ERH and F? Now we need to check the order. Print the order and in degree. Just the orders a bit more. N points to F, H point to E, R point to N, E point to R. Correct. Now the in degree. Print the in degree. Okay, so in degree is wrong there. In degree, I see. So I think to avoid confusion, correction Okay, let's just create the character directly. So C and N. Okay, C actually. Okay, let's just fix it directly. So next, okay. Yep. Now let's try to submit it. Hopefully this is correct. Wrong answer. Expected output is empty. So WRT yeah, it should be empty. But then it should be arbitrary, or do we not want that? Okay, so how about I comment out if it is uncertain? So ABC, so we know A, B, and then C. But here it says ADA, BC. So how does it know whether you want the DE or not? Let's go back to the question. If order is invalid, return an empty string. Okay, how about this? Because it's not clear in the question. And length of letter. Okay, let's try this. I still got it wrong. Our output is empty. So how does it differentiate? Or did I read it wrong? Okay, let's try to get the sample test case there. WRTKJ. Then we run it. Your output is expected output is empty. But why? We cannot tell whatever the order is. Okay, let's go back to here. String A is lexicographically smaller than A. Then a string B. If either the following is true, the first letter with a differ is smaller in A than B. There is no index I such that AI is not equals to bi, there is no index I, there is no index I such that ai is not equal. So all of the I is equal and the length are less than that. Yeah, so this satisfies it. It means that, yeah, but it doesn't tell us that the order is invalid. It just means that we cannot tell. Okay, alright, I see here. So the word is not ordered. So WRT is supposed to come before WRT KJ. Okay, I got it now. Because I assume that they are sorted, but somehow it is not. So here we need to check if length of curve if length of next is less than length of curve, return empty. Yep, now we got it right. So yeah, that's an interesting edge case. Because I read on the question that the words are sorted based on the rules of this new language. But turns out that it contradicts the question statement itself. So I think that is a bit of a confusion. Alright, I think we will stop here, everyone. So thank you.